Hi friends, welcome back in your math channel. Maths in Nutshell by Mahesh Sen. Today we have the question number 3 of the exercise 7.1, and in this question we have to determine the point whether these 3 points 1, 5, 2, 3 and minus 2, 11 are collinear or not. So we have to check it, either these points are collinear or not collinear. We have to check it, right guys? So first of all, what we can do here, I just want to inform you what is the collinear points or what is the collinearity property, right? And then we'll prove it and we'll check it if this collinear or not. So very first, I just want to inform you that collinear, if there is a line, okay, all the lines, all the points on the line, they are called the collinear points. Okay, so what is the property, what is the concept? The all the points on the same line is called the collinear points. It may be 2 points, 3 points, 4 points. So you can say there are more than 3 points or more than 2 points, 3 points, you have the collinear points, right? So the points should be on the same line, right? The second thing is, this is the definition of the collinearity or collinear points generally. But mathematically we'll prove it. How the coordinates are given, how we will prove it? We'll draw a line and we are taking some points on this line. Suppose the points are A, B, C, D, E, F, G, H. Any point you can take it. Okay, so I've taken it 5 points. All these points you can see the all points are collinear. Why it is collinear? Because all the points are on the same line. A line is there, a straight line is there, and the points are on the line. So these are A, B, C, D, E are collinear points here, right? So I think now you understood the collinear points. The points are collinear. Still we have missed with the collinearity with the mathematical proof. Okay, so we'll have to mathematical proof here now. What we can do, guys, there is a simple way that I just want to inform you that if the points are collinear, suppose all the 3 points we will take on the line. So we have to check these points are collinear or not. We will check, we cannot draw this key, these are on the line, and then we'll say these points are collinear. Further then we can go for the collinearity, or we can check the collinearity, then we will go for the mathematical proof. Okay, so mathematical proof may what we generally do, we have the sum of the any two. What I'm writing here, just try to understand the sum of any two, the sum of the length of any two sides or the length of any two line segments. Okay, so sum of the length of line segments, okay, will be equal to the third one. Okay, so how you can understand the sum of the any sum of the length of two line segments is equal to the third one. Okay, you can put here, yeah, why I'm telling you sum of the two, because there are 3 points. So you will take 2 points and the third point will be, the third will be equal to the sum of the two. Then you can say the points are collinear. Otherwise you will say the points are no collinear because the length of the first two, the sum of the first two line segment is not equal to the third one. Okay, so we'll apply this concept and this property here, by which we can say the sum of the two is equal to the third one, right? So third segment, the length of the third segment we will find out, length of the second and first, all the 3 segments we will find out. In the next step I'm just going to tell you how to prove it. Okay, right? So we'll draw one line and we'll draw one line and we'll put some 3 points, right? And 3 points, we have the 3 line segments, you can say, oh, and the 3 points are there. So 3 line segments in the next step. So let me write down. I hope so you understood up to this. Okay, you understood up to this what is the collinear points. Now we are taking the 3 points. Let A, B, C, which is given to us only 1, 5, 2, 3, and this 2, minus 11. These are the 3 points. Now we are joining these all 3 points, and suppose we are taking a line segment AB, BC and AC. These are the 3 line segments. One is AB, BC and AC, the bigger one, right? Now what you have to do, you have to find the length of this line segment. So first is AB. What I'm writing here, AB. So how to find out the length of the AB or line segment? X2 minus x1 whole square plus y2 minus y1 whole square. This is the basically the distance formula. By the distance formula you will find out the length of the line segments. So the first line segment is AB. So we are finding is AB. X2 is 2 minus 1 whole square plus 3 minus 5 whole square, this is y2 minus y1. When you're solving, 2 minus 1 is 1 whole square, 1 square basically, plus 3 minus 2 is minus 2, so I'm writing here minus 2 whole square. After solving this, I get 1 plus 4, 1 plus 4 is 5. So guys, the length of the first line segment, that is 5, the value of line segment is 5. I'll put in the box, no problem. Second thing, we'll find out the length of the BC also, that is the line segment, second line segment. So write the line segment BC is equal to x2 minus x1, y2 minus y1. The same concept will apply here. x2 is, you will put here the distance formula, okay. So x2 is minus 2 and y1, x2 is minus 2 and x1 is 2. So 2 minus 2, minus 2 minus 2 whole square plus minus 11 minus 3 whole square. Minus 2 is minus 4 whole square plus minus 11 and minus 3 will be minus 14 whole square. And just open the bracket, minus 4 square is 16 and minus 14 square. So you will put here 16 plus minus 14 square is 196. So I'll put here 196. When you are joining this, I mean adding this 16 plus 196, you will get 212. So the line segment BC or the second line segment whose distance is BC each other. Okay. So length of the BC is 212 under root. The last one is AC or CA. Both are same. So I'll go for the AC also. AC again by the distance formula, x2 minus x1 whole square plus y2 minus y1 whole square. x2 is minus 2, 1 and minus 11 and 5. So I'll put direct values here. You can see my screen that minus 2 and 1 and minus 1, that is 1 plus 2 and 5 plus 11 whole square. Okay, fine. This will be 3 square plus 16 square. 11 plus 5 is 16. 3 square is 9. So I'll put here 9 plus 16 square is 256. So 256 plus 9, 265. So under root 265 is the length of AC. And if you observe this all three values, these three values are root 5, under root 212 and 265. If you add them, you can say if you add them, AB plus BC will not be equals to AC because all are in fraction, sorry, in square root. Okay, so you can say further that AB plus BC is not equals to AC, hence the 3 points are not collinear or points are not collinear. So hence you just write the answer that the points are not collinear. This is the property of the collinearity when the any 2 points because these are the very simple. So we are adding directly and this will not, you will not get the any 2, the sum of any 2 is not equal to third one. So hence the point 1 comma 5, 2 comma 3 and minus 2 comma minus 15 are not collinear. I hope so you understood. We'll go for the next question after this. Question number 4 also. We have the question number 5 also. So I hope so you understood now. We are going for the next question. Right? Chalo, next. Question number 4. If you want to see it, you can see. Otherwise, go for the question number 4. Now see the question number 4. Again, we have to check whether these points are here. 5 minus 2, 6, 4 and 7 minus 2 are vertices of an isosceles triangle. So you have to check it. He is not saying this proved it. You check whether these points are vertices of the isosceles triangle or not. Okay. So guys, you should know the property of isosceles triangle. Then you can also, then you can prove it, right? So what is the property of isosceles triangle? Everyone knows because this you are in 10th class now. So we have learned many times isosceles properties, equilateral triangle properties, and the scalene triangle property. So isosceles triangle property is when the two sides are equal, okay, that triangle is called the isosceles triangle. Okay, so any two sides, there are 3 sides, so you can say any two sides are equal. So I am just writing for understanding, for your concept, for your basic knowledge, that isosceles triangle, because you sometimes you get confused here. So isosceles triangle is 2 sides are equal in this triangle, and which kind of the triangle having the 2 sides, that is called the isosceles triangle. After this, we have to draw this this isosceles triangle. Put the values of vertices ABC. 5 comma minus 2. A is the 5 comma minus 2. I put here 5 comma minus 2. B is 6 comma 4. So I will put here 6 comma 4 at the point B. And C is the last one, that is 7 comma minus 2. Now guys, you have to prove this. If these two sides are equal, then you can say only the sides are equal, then it is an isosceles triangle. So what you can do, you can just go through this and find out the length of the sides. If any two sides are equal, then you have the an isosceles triangle property, right? So what I'm writing here, first of all, AB is under root x2 minus x1 whole square plus y2 minus. This whole exercise is based on the distance formula we are practicing here, so that you people can get it. So this is my distance formula. Now I put the values x2 minus x1, a and b. So you can write as 6 minus 5. This is 5 comma minus 2 and 6 comma 4. So a and b. So b minus a. So I mean 6 minus 5 whole square and 4 minus 2. So minus 2 will become plus 2. So I will write here 4 plus 2 whole square. When I will simplify AB equal to this 6 minus 1 is 1 square plus 4 plus 2 is 6, right? So 1 plus 6 square is 4 plus 2 is 6 square. Yeah. After solving, after opening the bracket, I will write here 1 square is 1 plus 6 square is 36. So 36 plus 1 is 37. So I got the length of the first side of the triangle, that is under root 37. I'll put in the box also, and then I'll keep it me that AB is here with root 37. Similarly, we'll move for the second side also, BC. We'll find out by applying the distance formula. So I think now each and every time we don't write the distance formula. You know that x2 minus x1, y2 minus 1. So you can write here like this: 7 minus 6 whole square. I'm just going to write directly 7 minus 6 whole square plus minus 2 minus 4. So I can write it 4 minus 2, that is 4 plus 2, because the positive number I write generally first. So this is also correct. 7 minus 6 1 square plus 4 plus 2 6 square. 6 square will be 36 and 1 square is 1. So again I can say here this is 1 plus 36 is 37. So I'm writing here 37 is the side BC. So you can see here both the sides are equal, but we have to find the third side also for our understanding. But it is enough that you people have got that the two sides are equal, but I will suggest you just find out all the three sides, because he wants the proof that this is an isosceles triangle or not. So we generally find out the third side also, there is no problem. Just AC is under root. If you want to find out the value of AC, I mean the length of AC basically. So I don't know the point, so I will write here A is I think A 5 comma minus 2 and B is 2 comma minus. Sorry, what is B? Let me write it down. Sorry, A and C. You are finding A and C. So A is 7 comma minus 2. Okay, and I'll join these 2 points A and C. I'll find out by distance formula. So x2 minus x1 whole square plus y2 minus y1. x2 is 7, x1 is 5. So I can write here 7 minus 5 whole square. Yes, in the under root plus minus 2 and minus 2. So minus 2 will become plus 2 here. So minus 2 plus 2, that will be 0. So ultimately you are getting here under root 7 minus 2 is 2 square. Basically 7 minus 2 is 2 and square is there. So 2 square plus 0. Because minus 2 plus 2 is 0. Okay. So 2 square is 4. I can write here 0 square also. Sometimes you will get it. So under root 4 plus 0, that is 4. And 4 is 2. Under 4 is 2. So I got all the three values A, B, B, C and AC, the length of all the three sides. And I can see here AB equals to BC, which is under root 37. So I am writing here AB equals to BC, which is under root 37. Hence our triangle is an isosceles triangle, or you can say in the last key ABC are the vertices of an isosceles triangle. That is my answer, and this is the solution of the question number 4. I hope so you understood the solution, all the concept by isosceles triangle property, and what is the property of isosceles triangle, what is the collinear property, all the things. So finally answer you will write ABC are vertices of an isosceles triangle. This is your answer. Fine.